Hi, Namaste. First of all, it's been like 208 days since the last video, so where was I? What was I doing? Well, I've been busy designing and building all of this stuff. See here. So what do we have here? First of all, the USB-C power supply, the Pico cell, FM radio module, radio active. Well, this one is quite interesting one because this one runs off an Arduino, so this one can be highly customizable. Then we have the output mixer, fuse, analog generator, and H.A.V.O.C, plus 3 accessories, blank panels, 2 HP, 4 HP, 6 HP, floating attenuators. These are like basically just 10 pots. A passive Eurorack power bus, the Optimus. Now, all of these things you see here are available on the website right now, so you can check them out. I will put the links down in the description. But this video is all about this thing called HAVOC. So, wait a minute. Now, HAVOC stands for Hybrid Analog Voltage Oscillations Controller, which is not an analog computer, but purely a building block for audio synthesis. So to understand more of this, we have to look into the problem first. Now let's assume we want to build a device which does certain things as you want, like controlling LEDs, reading sensors, communication with other devices, controlling steppers, servos, etc., digital signal processing, you name it. For that stuff, like you have tons and tons and tons of options on the internet, like you can find from very cheap to all the bells and whistles you wish for. But when you step into the analog signal processing, well, you are limited to pretty few boards. Now let us assume you want to build your own analog synthesizer from scratch. So you look for the info on the internet and you will find the schematics directly like this, or you are pointed towards the ICs, which I put here, which can get pretty daunting if you are not into electronics or new to electronics. If you can use something like SEM boards and get away with DSP and FIR, IIS stuff, but if you're into it, you know that it can get pretty complicated, well, relatively complicated pretty fast. On the other hand, we have the analog stuff specially designed for audio, so why not use that? That is exactly my point here. So HAVOC is purely an analog synth building block which comprises a robust oscillator core, low pass filter. We have 2 analog filters here and a tiny microcontroller to control everything, so which makes it a full analog synth voice designed to be mounted inside your Eurorack module. So of course I will hit you with the nerd stuff right now. So first of all, the power supply, I will put the pin diagram here somewhere. So this chip runs on plus 12, minus 12 volts. So, and of course you can see we have the standard Eurorack power connector here, so you can run this off from your regular Eurorack power supply as well. We have onboard plus 5, minus 5 volt regulators. This comes in handy because all of the HAVOC's parameters are controlled on the scale of 0 to 5 volts or minus 5 to plus 5 volts. The oscillator here is SSI2130 from Sound Semiconductors, which is a pretty robust design. And we have all the use of an oscillator, so we have of course the standard 5 wave shapes here, soft sync, hard sync, 2 volt per octave inputs. Also with modulation control, we have onboard mixing circuit to mix few of the sounds through 0 FM, and of course ring modulation as well. Now the filter is SSI2144, which is a low pass filter which can be used independently. Same with the 2 of the oscillators from SSI2162. All of these ICs are from Sound Semiconductor. So one of the amplifiers can be used independently as well. To control few of the parameters, we have a teeny tiny microcontroller at Tiny85 on board here. This is running a DigiSpark design, so can be programmed directly from USB. We have an optically isolated MIDI input circuit, and last but not least, we have 2 op-amp inverters right down here. So yes. Now let us quickly look at some of the applications of this. As I said, HAVOC is a full analog synth voice, so that's Eurorack module right there. Well, of course I designed it too. The design is not final yet, but you get the idea, right? the oscillator, filter, amplifiers, and MIDI to CV thing all inside a 20 HP rack module. So sweet. Now let's keep things up a notch. What about multiple HAVOCs? Don't you want to build your very own Novation Peak or like a big Roland Juno system, something like that? Just imagine using a main bigger microcontroller to control all the switches and 4 of the HAVOCs inside the system to create your very own 4-voice true polyphonic synthesizer. Now, true polyphonic is the main reason here because you can have all the synths with multiple voices but with limited control over each of its features like filters and amplifiers. But with the HAVOC, you have individual control over each amplifier, filters, and oscillators. With this approach, you have individual control over each filter and amplifiers as well. And if you are paying attention, I'll put the second amplifier here specifically to chain multiple HAVOCs and create a polyphonic synthesizer, right? So what do you think? So where do we go from here? Well, first I have to check even if this one works or not, because this is the first iteration of the PCB. I mean, like, I do have the PCB, I do have this sensor, but I'm still waiting for a few of the components to arrive. This will be available shortly after that. Now we are starting a GitHub page and a Reddit forum for the same, because I mean, like, I do have already the idea for HAVOC 2.0. This is just a proof of concept, right? I mean, some of the ideas are like you can replace the H.A.V.O.C microcontroller with ESP-BO. So with Wi-Fi and Bluetooth, like, we can stream this audio directly into a VST inside Ableton. So generating analog sounds here and processing directly them into the computer. Yes, there are limited possibilities here. Let me hear your thoughts in comments down below. I will see you all at the forum, and as always, peace out.